You are welcome to Dr. GB classes. In this classes, we are going to study about the Karl Pearson correlation coefficient. In the previous section, we studied definition and types of correlation. But today, in this video, we are going to study about the Karl Pearson correlation coefficient. It means how can we calculate the correlation between the any two variable. Now, let's start with the definitions. It is a simple ratio of the covariance of the two variables to the product of the standard deviations of the two variables, and it is simply denoted by R 1 by 2. It means correlation is just a ratio of the covariance to the product of their standard deviation. Now let's see. Okay, so correlation. Here is a correlation is denoted by R 1 by 2. R 1 by 2 means here is 1 and 2 represents the two variables. Means we have one variable is a x and another variable is a y. So we are going to establish the correlation between the two variable x and y. So simple formula of the correlation. To determine the correlation coefficient, we use this formula. But exactly, it is a ratio of the covariance. This above is a covariance, and here is a product of two standard deviation. Hence, Karl Pearson correlation coefficient. Karl Pearson correlation coefficient can be defined as this is the whole is a ratio of covariance to the product of standard deviations of the two variable. But to determine the correlation coefficient between any two variable, we use a different formula which are discussed here. At first, now discuss two formula. Here is one is a direct method. In this direct method, we use a direct formula to calculate the correlation between any two variables. Here is a xy and xy. Here is a n and is the numbers of observation and x squared summations of x squared. So first of all, we have to remember this formula. If you can remember this formula, from this formula we can derive all the other formula. So our main basic formula is this. So we have to remember this precisely. Okay, in the actual mean method, sometime we can use this formula also. In the later sections, I will tell you in which time we have to use which formula. Okay, so here is the actual mean method. Means if you know x and x bar, y minus y bar. So here is a small xy. So small x means x minus x bar. X bar is a mean. Actually, x bar is a mean. X bar is a mean which you can calculate by summing total x over by total numbers of observations. Similarly, you can calculate y bar. Y bar is a means of y. So this is the actual mean method. Sometimes if data are too much and tedious data, at that time we use a next formula. Okay, now when we have a large data is not very simple, and if the data are too large, at that time we can use a different formula. Another two methods are assume mean method or shortcut method. So in this case, we consider a assume mean. Here is A is assume mean and B are the assume mean, and X and Y are the two variables. So by using these, also we can calculate the correlation between two variables. This method is applicable and useful when we have a voluminous data. Voluminous means if we have given the more than 2-digit data like 32,000 yes or something like this, then at this time we can use this formula. This formula reduces the voluminous data into a smaller form. And another method is also a step deviation method. This method is also useful when we have a given voluminous data as well as we have given fractional data. At that time we can use this formula. So and this formula is much more useful when we have given a class height, that is k is also class height or class size. If our data are given in the range like something's 10 to 20 or something that is 20 to 30 like class, if the data are given in this class, in this way class, then we can use this formula. So here we have studied once, that is a direct method, and another is the actual mean method, and here is in third assume mean method or shortcut method, and here is a step deviation method. But I suggest you only two formula. One is that is direct method. Remember this formula. Yes, if you remember this formula direct method, then you can derive all those formula. Look at here, in the x and y, in place of x and y, we have written u and b. This formula, this one number formula and three number formula are same. Only we have replaced x and y with the u and b. Otherwise, all the values are same. And also here is all values are same. We have only here is ub, but here is a u dash b dash. Only different is that in this third number we have used only a ub and variables without dash, here is a dash. So only difference is that, but this formula, that is step deviation method, is applicable only when we have given class height or class size. Applicable means it can be easier to use when we have given a class height or size. So these are the four formula. Remember this one formula, and another one is this formula. But if you remember first formula, then you can derive or remember all those four formula. Okay, now let's start with some examples. Okay, before starting the example, first of all, we need to understand interpretation. How we can interpret the result is, we have obtained this value of r. R is a correlation coefficient between two variables. So how to interpret the result? If the value of r obtained by using above formula are exactly plus 1, then it is called perfectly positive correlation. Okay, if you have some confusion regarding this, I want to suggest you to watch my previous video. In the previous video, I have explained all the result. Okay, so here is a one, when r equal to plus 1, then perfectly positive correlation. But when r equal to 1, then perfectly negative correlation. But if there is a r equal to 0, means no correlation. Yes, if the value of r, that is a correlation coefficient, it is a correlation coefficient equal to 0, then there will be a no correlation between any two variable, say x and y. But during interpretations also we can use other values. Okay, these three were the first basic interpreting value, but also we can use other values like this. If the value of r is 0.7 to 0.99 or 0.7 to minus 0.99, then said to be a high degree of positive. It is a high degree of positive, and it is a high degree of negative correlation. It means if our value lies in between 0.7 to 0.99, then it is said to be a high degree of positive correlation, and if our value lies minus 0.7 to minus 0.99, then it is said to be a high degree negative correlation. But when our value is lies in between the 0.5 to 0.699, then it's said to be a moderate degree of positive correlation. But when r is less than 0.55, then said to be a low degree of correlation. But what I want to suggest you is that do not remember all these interpreting value. If you can remember, if the r equal to plus 1, minus 1 and r equal to 0, then these three values are enough. Okay, so if the value of r equal to positive, then it is said to be a positive correlation. Yes, if r equal to negative, then it is said to be a negative correlations. So if r equal to 0, then it is said to be a no correlation. So if you remember these three basic things, then you can remember all those interpreting values. Okay, now let's start with some examples. Okay, now we have a question, that is the table below gives the ages and blood pressures of 10 patients in a clinic. Okay, we have one is a age and another is a BP. Okay, here we have to find out the correlation coefficient between age. Here is a one, we have the age we have this one is a age, and another is a blood pressure, that is a BP. So we have to find out the correlation coefficient between age and BP. It means if the age increases, whether BP increases or not, we do not know. And sometimes when age decreases, BP increases or not. What types of relation is there in between the age and BP? We have to determine it by using the correlation coefficient. Okay, now comes to the solution. Okay, now we have a solution. So let x be the age. First of all, we have to suppose these two value by two variable. One is x, so x be the age and y be the blood pressure. Then when we have to find out the correlation coefficient between in these two, age and blood pressure. Then we will use this direct formula. Okay, so you can use always this formula. I have already told you that you can use this formula always. But when if the data are given very large and voluminous, at that time this formula become more difficult. But if you do not think as a more difficult, then you can use this formula always. Okay, this is the direct method. Yes, already we have studied that in this section. This is the direct method, and direct method or direct formula to calculate the correlation coefficient between two variables. Okay, now we'll construct a basic table to calculate this. Okay, here is a format of table. To calculate the correlation coefficient between any two variable x and y, we have to format the table. So here is a x, here is a x, and another is a y, and here is a xy, and an x square and y square. Actually, you do not have to remember this format. This format are from here is in our formula. Here is a xy, so we have also calculate here xy. Here is a x and y. Here is x and y, so here is also x and y. Here is a summation of x square. It means we have to calculate the x square. And here is a y square. Here is also y square. So we have to format the table to calculate the correlation coefficient between any two variable. First of all, when you add all the value from here in column, we'll get the summations of x. Summations means addition. Okay, when you add all the value, then we'll get here is summations of y. Similarly, summations of xy, and similarly summations of x square and summations of y square. Okay, now let's calculate. Okay, here we have construct the calculation table. Here is we have a calculation table. So here is a x and another is a y, and xy, x square and y square. These are same as the previous this format table. We have suppose age is equal to x, age equal to x, and this is a y. So we have written all the values from here in the column x. Here is a 56, 42, 36, 47. Here is also 56, 42, 36, 47. Okay, all value we have copied here. So it represents age. It is a age s, and this represents blood pressure BP, and that is y. So we have written here, and xy can be calculated by multiplying value of x and y. So when you multiply 56 into 147, we'll get the 8232. Similarly, when you square this x value, means when you square the 56, then we'll get the 3136. Similarly, when we square the 42, then we'll get the 1464. Similarly, we can calculate the y square. Y square can be calculated by squaring the value 147. 147 square equal to 21609. Similarly, when you square the value 125, then you will probably get the 15625. So in this way we can calculate all the values which are required in this formula. Okay, so now finally we have added, when you add 56, 42, 36, 47, 49, 42, all the value, then we'll get the summation of x, that is 522. And in the next way, so when we add all the value from in the column from above to below, then we'll get this value, and similarly we'll get this value and this value. All these value will obtain. Now when you put all this value in our formula is here, so this is a formula, then we'll get the result. Okay, now comes to the result. Okay, we have this formula. I have already told you that this formula is a direct method formula. Okay, by using this formula, we can calculate correlation coefficient between that's age and blood pressure, that is in between the x and y. So this is the formula. Here is a sample size or observation size. Actually, observation size is 10. If you count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have used n equal to. Here is a n equal to 10. N equal to 10. So n equal to 10 and summations of xy. Here is a summations of xy 75188, 75188, and here is a summations of x from here 522 and 1417. Summations of y equal to 1417. And if we put all the value obtained from here table, this is a calculation table, then we'll obtain the result. Okay, now we have to interpret the result. Actually we have a 0.89. So let's come to the first. Here is in the interpretation sections, r equal to 0.5 to 0.69, then said to be a moderate degree of freedom, sorry, a degree of positive correlation. But we have a 0.7 to 0.99, then said to be a high degree of positive correlation. It means our value is above the 0.77 and below the 0.999. So this value shows high degree of positive correlation because we have obtained the positive value, and also our value is lies in between the 0.77 to 0.99. It means it is a high degree of positive correlation. High degree of positive correlation. Okay. In this way, we can calculate the correlation coefficient between any two variables. So these are the basic things to calculate the correlation coefficient between any two variables. Okay, if you like this video, then please subscribe my channels, as well as if you have any questions regarding statistics or this topic, then you can comment and also share to your friends and neighbors so that they will inform and they will get the knowledge from here. Okay, thank you for watching.